Good afternoon, guys. We are starting the sessions now. And thanks a lot for coming on the weekend. And as usual, like React Bangalore doesn't like fail to impress. Like look at the crowd that is like gathered. So has anyone attended any of my previous talks? Okay, that's like, wow, thanks guys. Thanks for coming again. I really hope I could like share something really valuable for you because you are like investing one of your weekends to like attend this session. Cool. So today's topic that I'm going to talk about is actually the product that we are working on. It's an open source GraphQL API gateway. So this is called Wundergraph. So you might be like wondering about the title, like how to build a backend for frontend using Wundergraph. So what is this backend for frontend? What is this concept? So has anybody like heard about backend for frontend before? Or like, okay, I'm seeing like a few hands. So to make this talk like beginner friendly, like to make it accessible for everyone. So let me go back to the basics. So what I'm going to do is I'm going to walk you guys through what is the problem. Why do we have this pattern called backend for frontend and where Wundergraph actually comes into play to solve this issue for us. Okay, so to quickly get things started. So this is a very traditional web application. So, sorry about it. I just used Excalibur to draw this. So nothing fancy over here. So we usually have like a server, you have an API, and you have a web application. So usually what happens is you have like a React application that runs, it makes a fetch API call to the server and the server responds with the data. So that's a traditional app, things work. Now, as the projects get complex, as the team grows from 5-member to like 500-member team, okay, what happens is the complexity of the backend and front end like changes, especially like lots of companies tend to like move towards this microservices architecture. So what you will have is you will have this thing called the modern tech stack, where you have like front end filled with like JavaScript, Apple, Android, all of this front end tools, and you have this glue in between an API layer, and you have this backend. So backend contains all this AWS, Node, all the fancy stuff that different developers use. And eventually what happens is to glue these two things together, you tend to use one of these like GraphQL APIs, and you often have to use Stripe, Twilio, all of these other API providers. And finally, you have like a very, very messed up layer in between. Basically, like whenever like there is an issue happening, most of the debugging like goes between backend versus front end. Like there is something wrong in the API, but everyone won't agree on like what data format went wrong. So this kind of complexity arises because when you are actually coding, you have this thing called type safety. When you are using TypeScript, Java, .NET, like if you are going to call the function, like this is the arguments that I have to give to the function. But as you are like trying to build APIs, especially REST APIs, what happens is you won't exactly like will be confident about the type safety. Like GraphQL came in to solve the problem, but still GraphQL has its own set of issues, which I'll be like discussing in the next slide. So this is how a general microservices architecture comes into picture. So what happens is there will be like different services. Say, for example, you are like building a shopping application, like you have the cart as a service, you have checkout as a service, you will have the product catalog as a service. Like different teams will be working on this. This is the interesting part because like not every team is the same. Like some people tend to use like lambdas for their functions. Some people tend to use like GraphQL. Some people tend to use like OpenAPI. But when it comes to like working in a single product, at the end, you have to like deliver a focused product to the customers, which means all of this different services at one point will have to like talk to each other. Correct. So what happens is it's like a different team building like different items, but at the end, when for the user, it's like a single product, which means inevitably these APIs tend to have like dependencies between each other. So microservice is not a bad thing. Microservice is very important because otherwise teams won't be able to move fast. And unless it's a monolith, a code change can actually bring an entire server down, which is like very risky. So you tend to use microservices, you tend to go into an architecture like this. But now what happens is these services will start gathering like dependencies within themselves. So what happens is service 1 will depend on service 2. Service 1 will depend on service 3. So for example, let's say we have like a scenario where I need to know all the launch pads in SpaceX. Okay, I'm about to like launch a rocket. I want to know what are all the launch pads available. So you make an API call, you get all the launch pads. But you also want to know what is the weather in each of these launch pads. So now what happens is there's a second API, weather API provider, who will tell you like this launch pad in this region is gonna have a sunny weather. Another launch pad is gonna have like a cloudy weather. So eventually what will happen is you will end up like writing a code like this. So you will have this thing called fetch landing pads with weather, and you first make a fetch request to get all the landing pads. Then you basically like run a map over it, get all the locations as an array, then make another API call. That basically, if you give an array of locations, it will tell what is the weather in all of these locations. And you can think of like writing it in backend or frontend. It doesn't matter. Like this code will introduce like a dependency, service level dependency between two different microservices. And now what happens is if the service 1 or service 2, they change their contract, it will come down to this function having to like make sure all the changes are applied. Now you can take it in a much real world scenario, like how many such functions will exist in your code base. Because anyone who is using the function, any developer who is like calling this function will just call this function without like understanding how much services are connected. So if this function fails, there will be like a lot of time spent on debugging what happened, which API like threw the error, which API didn't get the required data. So next step in this evolution is you have multiple front ends also talking to like different services. So those services themselves have like so many complexities and so many connections between them. You now have like a web app, mobile app. Sometimes you also have to provide external API for other developers to work with. So eventually what happens is there is a kind of like a messy situation between the APIs, because now no one team can claim ownership of this API. Correct. So if you take a team that is like managing service 1, okay, they have a dependency on service 2, which means 2 teams are now owning that one API. And the service 2 team, they have like a very unique challenge. So let me go and like show what's happening within each of these services. So service 1 team, they have their own tracing setup. They have their own authentication logic. They have their own logging, all of this like neatly figured out in service 1. But unfortunately, service 2 doesn't have any such setup. It might be because like service 2, the team didn't had enough bandwidth, or it is a new service that was built overnight. So there is like nothing much available. And service 3, what they have to do is they have to build 2 different authentication mechanism. One for the web application. This is how web application is supposed to authenticate. Then for the mobile application, they have to build an API auth for mobile, which basically instead of using cookies, it will give like tokens and read the request headers. So now we have like a very distributed API setup where each team have to like manage their own infra on how authentication is supposed to happen, how logging is supposed to happen, how tracing is supposed to happen. And overall, the complexity will skyrocket if we add like more things like caching, rate limiting, different set of like scenarios where teams have to like manage how their APIs are supposed to work. And this kind of like setup over a period of time tends to like cost a lot of time for companies, because you might see that one of your service 2 might be like performing a little slow, but it actually doesn't have tracing setup. So you might not know by looking at tracing. You'll end up having to build a different tracer for the service 2. Now, service 3 might be like having issue with authentication. Okay, but other services will work. Only service 3 will start throwing like 401, 400, and users might not know. They will think a part of the application is not working. So there is like a lot of moving parts in the place where we are combining APIs together for the end user. And is there a way we can like eliminate these moving parts? Is there a way we can like make things much easier to work with? So this is basically where Wundergraph comes into the picture. So we are like not on the developer level, not on the front end level. We are in between. We are like making sure the backend works for the front end. We are making the backend extremely simple for use, simple to consume on the front end. Okay, and there is like a huge definition on backend for front end. Like you can have like a single backend gateway or like multiple backend services. But let me explain in a much simple terms so that everyone can understand. After which you can go and actually like catch up on the actual definition on what is this backend for front end concept. So let's start with what is Wundergraph. Let me open up our homepage. So there are like three things that we focus much when working with Wundergraph. Wundergraph is completely open source. Anyone can try it straight away. I'll also like show you guys code samples in the next steps. So first thing is APIs as dependencies. So think of APIs like npm packages. Like how do you install npm packages? You install Lodash, it installs Lodash, and along with it, it will bring all the dependencies together. So when you call any function, you don't have to worry about all the dependent items on the Lodash. So Wundergraph focuses on making your APIs as dependencies of your front end. So you can call them without actually having to worry about breaking anything. Second, it's gonna live right next to your front end code. It's a backend for your front end code. So the idea is, if you have worked with Firebase by any chance, you know the developer experience on the front end. Like you literally do firebase.db. It will tell you all the collections you have. It will tell you like all the arguments, all the filters, everything you can apply to the Firebase. Now Wundergraph actually brings the developer experience to every backend. So what happens is we will build a gateway that actually knows what are all the operations available, and we generate TypeScript code so that when you are integrating with your application, you already have type definition for everything in your API. So the backend is going to be like living right next to the front end, and you have end-to-end type safety. So this end-to-end type safety makes life a lot easier. Like imagine you change some value in your backend in some service. Say that you changed some contract in service 2, and have like TypeScript lint checker run and actually tell you like these applications are gonna break. Now that's gonna actually like save some serious runtime issues on the production. So let's see how Wundergraph achieves this. So in Wundergraph, what we call all the APIs is that we call them as data sources. So on the left, you can see pick whatever data source you want. And on the right, you can see the Wundergraph config file. So what happens is you set up a configuration file that tells where your data is going to come from. So in my case, say that I have like a SOAP API. So we have the introspect option, and basically that reads all the SOAP API, and say I also have a Prisma file. And Wundergraph not only reads from APIs, it also reads directly from databases, which means you can actually skip writing a backend for the database and actually connect the database into Wundergraph, and you can write operations directly on the database. So you can select your data source as Prisma, and you have to give the schema file to Wundergraph so that it interpolates the schema file and actually tells you what and all operations that can be run. And if you have like a GraphQL or like a OpenAPI compatible data source, for example, you have like a Shopify API that you have to like connect. So Shopify also can be like introspected. So you just have to like provide a namespace, you have to provide a URL, and now the interesting part is Shopify has an authentication mechanism associated with it. So what happens is every request coming to Shopify, you have to provide a secret in its header because it's a third-party service. They have a different way. So I can actually like provide a property called headers and build a static header directly in the gateway. So this is still in the configuration file. I'll say whenever there is a header, a request coming to Shopify, attach this static header to the request. And you can take the value from an environment variable, which will be a secret on the server. So now what happens is your client doesn't have to worry about this header anymore. It can just call any Shopify APIs like a normal API, and it will get the response. So all the complexity is already like getting abstracted away. And here is the most awesome part. What kind of authentication you want for your APIs. So if you want auth0 authentication and it's cookie based, you can directly like provide cookie based auth provider. And these are all the auth0 secrets for generating issuing the token. So now what happens is all the API that we introspected, we took from Postgres, Prisma, Stripe, everything are now behind an inbuilt authentication mechanism. And you can also provide multiple authentication mechanisms. Say that I want to add a GitHub. You can add a GitHub auth provider. Now you can easily set up a login with the GitHub. And once you log in, the gateway automatically knows this is a logged in user, and it can focus on making the actual request without worrying about which service, which authentication mechanism it has to like work on. So now you can see we are like kind of connecting all the backends together. Correct? We are connecting all the backends together, and we are like generating a single usable like gateway. Then on the front end, we are providing like SDKs. which basically means you have React Query SDK. And this React Query SDK actually knows all the possible APIs that your application can have. So now what happens is you can directly do use query and call the operation with the operation name itself. And all the input and everything will be like fully type safe. And our SDK also like supports multiple frameworks. So you can use it with Vue.js, you can use it with Svelte, and Relay is also supported in case any hardcore GraphQL fans are here. And finally, the goal is to like ship fast without breaking anything. So now you have like all the power, like all your APIs are going to be type safe. You know where the data is coming from, what authentication mechanisms are being used. So finally, you have a very solid understanding on how to ship things fast without breaking stuff. Okay, so let's try doing an hands-on session, like how I'm gonna like combine all of these APIs together. Okay. So I have like two GraphQL APIs here. Okay, one is a SpaceX API, another is the weather API. This is the example I was telling you about. So in SpaceX API, I can actually get all the launch pads that are available for an aircraft to launch, spacecraft to launch. And in the weather API, I can actually like give a region and ask like, what is the current weather situation? How is it like going on? So let's take a look at these APIs. So first, let me go and check out the SpaceX API. So SpaceX is a GraphQL API. So I can do a query and I can get all the launch pads. This will actually like list all the launch pads that is like available in the given time. Then I'll also take a look at weather API. Where did I put? This weather API is also another GraphQL API. So if you look at this API, it says get a city by name. And if you give the city's name, okay, it actually like runs and gives you the data that is like needed by that specific city. Okay, now let me go into the code. So what I did here is I used one of the Wundergraph boilerplates and generated a code base. It's a Next.js project. This is available in our Wundergraph getting started page. We have like different templates for different kinds of projects. This is the Next.js template. So what happens is you will get the entire Next.js application. So this is a Next.js app. So if you have worked with Next.js, this is how you create pages. This is how you like add tests and everything. This is normal Next.js, and you get a .wundergraph directory. So, okay, let me zoom in. Okay, hope it's visible now. Cool. So you have the normal Next.js project, and you also have the .wundergraph directory. This is where the Wundergraph GraphQL server lives. So in Wundergraph, what I can do is, in my config, what I have done is, I'm basically like creating two different API namespaces. So namespace basically means it basically restricts all the API operations under like one single prefix. So all the SpaceX related operations will be like called SpaceX underscore the operation name, and all the weather related operation will be called weather underscore the operation name. So I'm telling Wundergraph to introspect both GraphQL endpoints, and finally like set up a new GraphQL application server. Not only that, I'm also telling it use the code generator and generate TypeScript client for my created operations. So now what happens is Wundergraph will connect both data sources, read my operations, and basically like generate type safe API clients, which means no longer I'll have to write fetch or anything. I can directly import this client and directly call the operation name, and I'll get the API responses. And these are all like auth providers, cookie and security and all the other configuration. So let's go and see how Wundergraph lets me like connect these two APIs together. So let me start up the Wundergraph server. Okay. Cool. So you are looking at the Wunder node UI. So this basically tells Wundergraph has started, and it gives the version number and the commit info from GitHub. It doesn't give any other information. Now I want to construct an operation that basically connects these two independent APIs together. Okay. So what I can do is I can just go to like slash GraphQL. Okay, there is already like the connected code. Let me just comment it out and explain it again. Cool. So my goal is there is a Launchpads API. There is a weather API. I need to like get all the Launchpads and their corresponding weather information. So what I'm going to do is I'll start with writing a simple query. So this query name is going to be like Launchpad with weather. If you actually like look at the documentation of this GraphQL endpoint, so Wundergraph leverages GraphQL for making sure you are like finding it easy to set up these operations. So whatever operations I'm going to write here is the operations that the clients can call. Okay. So all the SpaceX operations you will see are prefixed with SpaceX underscore. And all the weather operations will be like prefixed with weather underscore. And the GraphQL playground will actually give you full autocomplete, how these operations are going to work. So let me like add the SpaceX Launchpads operations. Okay, so this is an API that just calls SpaceX landing pads. Actually, I should be looking for launch pads. My bad. So if I click run here, it will like run and bring me all the available launch pads. Now, if I go to my weather API, so it is get city by name, and I have to give it a city name, and I can actually see from the response that I got, the region is available here. This actually is the city name. So if I can take this region and provide it to the city in this exact query itself, it would technically like combine both APIs together into a single endpoint, single query. So to do that, Wundergraph actually provides some nice GraphQL decorators that I can use to construct this relationship. So let me show you how to like define a join operation between like two data sources. So I just defined an argument to launchpads with weather called region, and I'm going to add one small decorator here called internal. So this basically tells, it's a GraphQL thing. What it tells is do not accept region from the user. Instead, one of the internal fields that you have is actually going to expose the region's value. And the field is actually here, this region field. So what I can do in this field is I can write an export. So with this, I have actually like exported this region. Then finally, what I can do is to join this data with the other API, I can write an underscore join. So right below my location, I'll write an underscore join. Just have to call get city by name. Remember, previously it was get city by name, but since we are in Wundergraph and we have assigned namespaces for the city name, it is actually like getting prefixed with weather. So I just have to like pass the region name here. So the region argument that I got previously basically like goes to the region field and it exports the region and finally like joins with the city API. For the arguments, I think I can get the arguments from the playground. And if I click play now, it would actually like now bring all the launch pads saying that this is California launch pad, which is in the Wundergraph Air Force Base. And it actually joins with the California's current temperature. So the weather data is also available for each of these entries. Now with this, we no longer have to like write code anywhere else to like combine different services that need relationships. And then here is the best part. I can like write this operations under the operations folder inside .wundergraph. So I have like written it there. Launch pads with weather.graphql. Then what Wundergraph will do is it will generate some interesting files for me because it knows what are all the data sources available and it knows what are all the operations that I need. So what I get here in the generated folder is first I get the client.ts file. So this file basically contains type safe definitions and functions needed for making this API call, which means as long as I use any form of TypeScript, I can just import this client and actually call this API. Then I also have the Postman collection, which basically means I can just import this collection and immediately my entire Postman will be like filled with all the possible operations. It will be really useful for testing. And I also have OpenAPI.json, which means it is available as OpenAPI. If you have like any legacy client that needs OpenAPI to work with, you are sorted. And you also have the GraphQL schema, which basically means in chance you want to use this gateway as a GraphQL server, you also have provision for that. So now what we did is we took two different APIs with like two different data sources across. We combined them together under like one single Wundergraph node, and we basically like provided a type safe environment for the front end to work with. And here is the interesting part. It doesn't stop here. Now the teams can actually focus on building the business logic alone because Wundergraph takes care of all the traces and logs across the API. Because if any API fails, right, Wundergraph actually knows which query failed and from which service it failed. So along with Wundergraph, what we provide is we provide this option called Wundergraph Cloud. So in Wundergraph Cloud, you can actually get this interesting UI. So this is the project that I was previously showing. This is like deployed to Wundergraph Cloud. You can think of it like Vercel for your backend. Because every time you create a new branch, Wundergraph Cloud actually like sets up a new node with all the preview environment variables, which means you get like full preview support across your APIs. And you can actually like go and see all the operations that are like running right now and how many calls are being done for those operations, which means you have like full analytics of all the services that is running, like P95 latency, errors, how often requests are coming in, and you have logs that is like across every single operation that is like being created, and you have tracing, which is recently released. Like the people who built are actually like sitting over there. So this tracing is like a really awesome feature, which actually tells you the path your API took to actually like retrieve the data. So you know all the services that are involved, and this is a live query, which means it repeatedly like checks in real time. So you can actually have all the real-time checks available across the traces, obviously along with the time taken for each of these responses. So now what happened is the whole option of like managing this API has been like simplified, and Wundergraph goes even a step further and it actually like integrates with Vercel. So now what I did is I actually integrated it with Vercel and I connected it to Vercel, which basically means it takes the URLs it generated from the Wunder node, puts it in Vercel, and also like sets up my front end so that my front end actually connects properly with the gateway. So after doing that, I actually have the working front end as well. So this is the working front end. It actually has all the launch pair locations and the weather conditions available. So pretty much most of these things are like a push to deploy flow, which means as long as you have the data sources and you want your front end to like connect, you just deploy to Wundergraph Cloud and connect your Vercel, and your entire application is like good to go. So both Wundergraph and Wundergraph Cloud are now available for free for everybody to try. So I highly recommend all of you guys to like go and give it a try. And we are really looking forward to your feedback. Now, any questions?